start listing the things such as size of farmable land, which is 500 acres, size and types of crops to be grown, acres of wheat and corn, labor demands, well, 1 person day of labor for each acre of wheat, 5 person days of labor for each acre of corn, labor restrictions, there's a maximum of 1,480 person days of labor, expense demands, $20 for each acre of wheat, $30 for each acre of corn, and expense restrictions, a maximum of $11,400. Her objective or goal is to make $90 per acre of wheat and $120 per acre of corn. Okay, so now that we've listed them, the information in list form, now we're going to define the variables. We're going to let x equal the number of acres of wheat and y equal the number of acres of corn. Okay, so after listing the information, it would appear that everything is relating to the number of acres of each type of crop that she grows. Both her labor and expense demands are based on a per acre basis. Her profits are also measured on a per acre basis. Taking all of this into consideration, we can best answer the question of what is the most profitable planting strategy by determining how many acres of each type of crop she should plant. So that's why we defined the variables the way that we did. Step number 3 is writing inequalities, expressing the relationship between the demands and the restrictions in the problem. So looking first at labor, hopefully you see that there is both a demand and a restriction. The demand is measured on a per acre basis for both the wheat and corn. Multiplying the number of person days per acre times the number of acres will give the labor person day amount for each type of crop. So for instance, multiplying 1 times x gives the algebraic expression which represents the amount of person days of labor for wheat. 5 times y gives the algebraic expression which represents the amount of person days of labor for corn. The sum of these two algebraic expressions represents the total amount of person days of labor. Now compare the demand with the restriction. If the maximum number of person days is 1,480, then the demand can't exceed or be bigger than the restriction. Therefore, we can write the inequality 1x plus 5y is less than or equal to 1480, which is our labor inequality. Applying the same type of thinking to the expense demand and restriction, you should arrive at 20x plus 3y, 30y less than 11,400 to be our expense inequality. Another restriction is the total amount of acres to be planted. Her farm has a total acreage of 500 acres. Therefore, the amount of acres of each type of crop can't exceed that amount of land. So another relevant inequality would be 1x plus 1y less than or equal to 500, which is our land inequality. Finally, we know that there are not going to be negative numbers of acres of wheat and corn grown, so we can safely assume that x and y are both going to be greater than 0, which I guess for lack of something better, we can call these inequalities our reality inequalities. So here's the list of inequalities with their ordered pairs that we use to draw their lines. 1x plus 5y is less than or equal to 1480. If I let x be 0, then I have the equation 5y is equal to 1480. If I divide both sides by 5, I'll get 296. Likewise, if I let y be 0, and I therefore have the equation 1x equals 1480, so therefore x is 1480. So I have those two ordered pairs in order to draw the line for that inequality. Doing the same thing with 20x plus 30y less than or equal to 11,400, I've divided both sides by 10, which gave me 2x plus 3y less than or equal to 1,140. And applying the same process, letting x be 0, let y be 0, I come up with the two ordered pairs 0, 380 and 570, 0. Using that same process again for the third inequality, and that one's fairly easy. If I let x be 0, y is going to be 500. If I let y be 0, x is going to be 500. And simply understanding that both x greater than or equal to 0 and y greater than or equal to 0 construct the x and y axis. So we should construct our graph looking somewhat like this. You notice that I looked at my ordered pairs. I'm seeing that my largest x value is 1480. Therefore, I went to 1500 as far as the objective or goal to make $90 per acre of wheat and $120 per acre of corn. So the profit is going to be the equation 90x, or the expression 90x plus 120y. So I'm going to take each of those ordered pairs and plug that into the expression 90x plus 120y to come up with the profit based off of that extreme point, off those extreme points. And we see that C, 360, 140, generates the greatest profit, 49,200. Based on the analysis, she should plant 360 acres of wheat and 140 acres of corn to realize a profit of $49,200. The details of this analysis is in a Word document attached